Our second lesson in this topic uses right-angled trigonometry to solve problems involving bearings. Bearings are a way of describing the direction of one place relative to another. We use two different types of bearings. True bearings, or three-figure bearings, are measured in a clockwise direction from north. Compass bearings describe a direction using the 8 points of the compass. In this example, we need to give the true bearing from the point O to each of the points J, K, L, and M. Imagine you are standing at the point O facing north. The bearing of J from O is the angle through which you need to turn to be facing in the direction of J. The angle between north and south is 180 degrees, so the bearing from O to J is given by 180 degrees minus 40 degrees, equaling 140 degrees. The bearing from O to K will be 180 degrees plus 73 degrees, giving 253 degrees as our bearing. The point L is directly west of O, so the angle through which you need to turn from facing north will be 270 degrees, or 3 lots of 90. The bearing of M from O is calculated by subtracting 18 degrees from 360, giving 342 degrees. In part A of this example, we imagine we are standing at point C facing north. We need to turn 64 degrees in a clockwise direction in order to face the point B, so the bearing of B from C is 64. In part B, we stand at point A and turn to face B. The angle through which we turn from north will be 180 minus 52, giving 128 degrees. In order to determine the bearing from B to A, we need to draw a north line through the point B. We now have a pair of parallel lines and can use our knowledge of angles in parallel lines to find the bearing of A from B. Alternate angles in parallel lines are equal, so we know that this angle is also 52 degrees. The bearing from B to A is then found by subtracting 52 from 360 to give us a bearing of 308 degrees. In order to solve this problem, we construct a labelled diagram to show the information described in the question. We form a right-angled triangle and label the unknown with a W, then use right-angled trigonometry to solve. This involves the hypotenuse and the opposite side to our 60-degree angle. Substituting gives sine 60 degrees equals W on 7. Isolating W, we get W equals 7 sine 60, giving a distance of 6.1 kilometres to 1 decimal place. To find the bearing on which the hiker needs to walk to return to their starting point, we draw a line through L parallel to our north line. This forms a pair of equal alternate angles. The hiker needs to walk on a bearing of 60 degrees to return to their starting point.